Hello everyone, I'm Dipanita. I'm your TA for the live interaction session of Fundamentals of Electrical Engineering, and this is the fourth interaction session. Um you have the lecture videos of various circuit analysis. Like in this week, you have been taught how to analyze different circuits, and we will be solving a few problems regarding the same. So, this is the first problem that we'll be solving. Um, you have been given a circuit as shown here in this figure 7, and in the question it is asked to compute the voltage V across this 36 ampere current source. So you have to find out this voltage. So for solving this circuit, you can either go for like you can compute the loop currents and calculate the voltage across this branch, or you can use KCL and calculate the branch current and compute the voltage across this particular current source. So we will be using KCL for this particular problem, but you can use both. I guess there are people entering, so let me just admit them. Yeah, so let's start off. um, yeah, so in order to apply KCL, we have to figure out which are the nodes, right? This is one of the node, this is the second node, and this is the third node, and this node is the reference node, right? The voltage here is V equal to 0, right? So let us assume this is V1, this is V2, and this is V3. Now we can apply KCL across all these three nodes and figure out the branch currents. Now once we know the like we can either figure out the branch currents, or you can calculate the voltage in across like of this particular node. So if you see, in order to calculate the voltage across this 36 ampere current source branch, what will it be? This V36A will be equal to V2, because the V2, then if the node voltage is here, which means the voltage across this particular branch with respect to reference is V2, which is what this current source is connected across. So we need to calculate this V2. So let us proceed with this. You can start off. I'll see if, yeah. Um, so in the first, for this particular node, that is at node 1. At node 1, 12 ampere current is going into the node. Let us just assume currents I1, I2, I3, which are coming out of the node. So if we apply KCL at node 1, what will it be? 12 is equal to I1 plus I2 plus I3. Right? Now, since the node voltage is assumed to be V1, you can compute using this equation. So it will be, just hold on, I'll get the pen. Yeah, so what will be I1 is the branch current across this branch, which is equal to V1, that is the node voltage here, minus the voltage here it is 0. So I1 will be equal to V1 minus 0 by 4. 4 is the branch resistance. We have solved similar kind of problems in our previous interaction session. So for the rest of the currents, I will directly write the equation in terms of the voltage. So it is V1 by 4. I2 is V1 minus V2 by the branch resistance 8 ohm. V1 minus V2 by 8. And I3 will be equal to V1. Now what is the voltage across this particular node? So there is no resistor or any other element connected in this branch. So this particular node will have the same voltage as V1. This will be the same node. So the branch current I3 will be equal to V1 minus, it has a voltage a source connected in the branch. So it will be minus of minus 120 minus V2. This is the node voltage. V2 by 4 ohm. The resistance in the branch is 4 ohm. Everyone agree with this? If not, you can speak up now. So everyone okay with this?
Yes, ma'am.
Okay. So you'll have to simplify this equation and write it in terms of V1 and V2. So if you are to simplify this equation, it will be like uh, we will like you can simplify it on your own. We can like move forward with the next node, like applying KCL at the next node. I mean, let's just write it out then, since this is the first problem. So it is, so you take the LCM of all the three, so it will be equal to 8, right? So it is 2v1 plus v1 minus v2 plus v1 v2. Let's take out this 120, since this is a constant term, we will just take it out. So it will be plus 120 by 4, so it is 30, equal to 12. Yeah, so basically it is 2 plus 1 plus 1, so it is 5. Sorry, it will be 2v1 and 2v2, right? Because denominator it is 4, so it is 5v1 minus 3v2 by 8 equal to um 12 minus 30 is minus 18.
Minus 18.
Yes. uh, yeah. So uh, since sorry, I took the highlight. So we have to calculate v2. Our aim is to calculate this v2, right? So what we can do is write v1 in terms of v2, because at the end then we have to solve only one of the equations. So we'll just write 8 into 18 is 144, right? So 5v1 equal to 144 plus 3v2. So v1 we can write in terms of 3v2 minus 144 by 5. This is one of the equation. The second equation you can form similarly by applying KCL at node 2. At node 2, what so it will be something like, so one of the this is, I'll take a different color, maybe then it will be better. So yeah, this particular I2 current is coming in, and at this node, since these two represent the same node, because there is nothing connected in between them, so it is ideally these two nodes are like, it is a big supernode kind of a problem. So basically I3 current is entering into this particular node 2 itself, and let us assume current going out. So here it is, let's say this is I4, I5. So these are current going out, and this is 36 ampere going out. So I3 current and I2 current are going in, I5, I4 and 36 ampere current are going out. So we can again apply KCL there. Okay. Huh. Now applying KCL and node 2 it is. Sorry, is anyone coming in? Yeah. So, guys, please do join in time. Otherwise, it's difficult to let in between. So, I2 is V1 minus V2 by the branch resistance, which is 8 ohm. So, it is V1 minus V2 by 8. Then, coming in is again the this I3, right? So, it is plus V1 minus of minus 120 minus V2 by 4. These two are current coming in, and going out will be equal to V2 minus of minus 240 minus V3 by 3 plus V2 minus V3 by 12. This particular so this particular one, and finally uh, plus 36 ampere, right? So you will have to simplify this particular equation, and the third equation will be at node 3. At node 3 the equation will be uh, so it is v sorry so 24 ampere current is going in, and rest of the current I5 I4 is coming in, and let us assume another current which is going out. So applying KCL here, it is v V2 minus V3 by 12 uh, plus V2 minus minus 240. Sorry, this won't be minus, this will be plus, because this is the positive terminal of the battery. So it will be V2 minus 240 minus of V3 by the branch resistance 3 uh, will be equal to, okay, again 24 ampere is going in, so it is 24, which is equal to I6 that is coming out. So it is V3 minus 0, since it is at the reference, V3 by 6. Now you have to solve these three equations in order to get V1, V2 and V3. So, I mean, you may solve it right away right now, or you may not do it right away. So from here you will get V3 in terms of V2. As you can see, there is no V1 in this particular equation. So just substitute this V3 of this equation in terms of V2, and finally plug it in this particular equation. That way this entire equation will be in terms of V2. Then you can simply just solve for V2, and you will like, if you solve this entire thing, you will get V2 is equal to something 86 point, just hold on, 86.23. So you can try it now. I'll give a minute or two, or you can try this at home. So everyone following up to this much? Anyone has any query about any specific thing, or everyone is okay with it? Can you please respond?
Yes.
So once you are able to calculate V2, you can simply go for the answer, right? Since across this particular current source, uh, the voltage is given like V36A will be equal to the node voltage V2. So it is directly equal to 86.23. Out of this four option D is the correct one. So we will move to the next problem now. In this next problem, you are given a circuit and there is a current source 5 ampere. What you have to calculate is the power delivered or received by the current source. So how would you like to solve this? Can anyone comment? So someone, can you please comment how you're going to solve it? No? Let me see if there is anything in the chat. So voltage across the current, right? So in order to calculate how much power is either getting delivered or absorbed in the current source, what you need is the voltage across this particular current source. So again, you can use the either the mesh analysis or the node voltage, calculate using KCL and calculate the voltage difference across this particular current source. So okay, let's solve using KCL. So let's assign voltage 1 here and voltage 2, since there are only two nodes here. So if we apply KCL at node 1, it will be V1 minus 5 across by the branch resistance 4 ohm. Guys, do try to join in time. So yeah, so let I1 current flow through this, let all the current go into the node. Okay, so 5 ampere is coming in like this. So applying KCL, I1 plus I2 plus 5 is equal to 0. So this is I1. So sorry, then what I1 would be? So then we cannot write V1 minus 5, right? Sorry, this is not getting it. So this, it will be 5 minus V1. So 5 minus V1 by 2 plus 5 plus, if current is flowing this way, then it is 0 minus V1 by the 2 ohm resistor. This will be equal to 0. So just take a, so it is 5 minus V1 plus 10 minus V is equal to 0. Sorry, this is V1. So 2V1 equal to 15. So V1 will be equal to 7.5. So we got the node voltage in this particular node. Then applying KCL at node 2. So 5 ampere current is going out. Let us assume I3 and I4 here. So 5 plus, it is V2 minus 0. V2 by 2 plus V2 minus 0 by 3. So V2 by 3 is equal to 0. So it is 5 um, half plus 1 by 3 into V2. There will be a negative sign here. So this, if you take the LCM, it is 5 V2. So V2 will be equal to minus 6 volt. Now that we have the node voltage of V1 and V2, can you calculate what will be the voltage across this particular current source? So it will be, let's assume there is, this is V. Can you calculate V? You already have the node voltages. So I would like you to calculate the value of V. Please calculate V and either unmute and speak up or write it in the chat box. So, are you able to follow this? Like, this is a resistance, this is a current source that is connected, 5 ampere, this is 5 ohm, and this is the end of the branch. You have this is minus 6 volt, you have this one to be 7.5 volt, right? And 5 ampere current is flowing through this particular resistance also, right? So what you have to do is calculate. So let's just yeah, let's take this as minus and this as plus, then it will be easier. So this is V. Just calculate. So since current is flowing through this particular resistance, how will the voltage drop be? Can anyone tell? Can anyone tell? Let's assume there is a V and there is a R connected across it, right? So what will be the voltage? V, right? If a particular current I is flowing through it. Similarly, 5 ampere current is flowing through this 5 ohm resistance. So what will be the voltage drop? Is anyone following? Let me check the right. So it is 25 volt. So I hope everyone is following this one. If not, you can ask. So since current is flowing from in this direction, so the voltage drop will be this way, right? So this will be equal to 25 volt. So if you look across this branch, what will like in order to calculate V, we can apply, since we already have the end node voltage. So basically it will be, so V1 is 7.5 plus we have this 25 volt and minus V, then this will be equal to 6 equal to 0. So everyone agrees with this? Everyone is agreeing with this? Respond with a yes or no at least.
Yes, ma'am.
Yes, ma'am.
Okay. I guess there is one message. Let me check. Yes, okay. So you can simply calculate V will be equal to 25 plus 7 minus 6, which is 1.5. So it is 20 6, so 1.5 adding to 25, 26.5, I guess. Now you can calculate, sorry. Um so yeah. Is this correct? Can anyone comment if I have written this equation correctly?
Yes, ma'am. Correct.
Are you sure?
Yes, ma'am.
Okay, then maybe I should explain it in a better way. So um, just think it in this way. If you apply, so forget whether it is negative or positive right now, okay? Just think this is V1, there is a resistance, there is a 5 ampere current source, and this is V2, this is 25 ohm. So let us assume a voltage across this, and the voltage across this will be 25 volt. Now if I write the branch equation of this, what will it be? V1 minus of minus 25, right? Minus V. So these are the voltage drops that's happening, right? This will be equal to the net voltage which is in this particular node, V2, right? So V1 is 7.5. You take this one out, 25 minus V, and V2 is minus 6. So if you bring this side, it will be 7.5 plus 25 plus 6, right? Not minus 6. Are you following?
Yes, ma'am.
Okay. Then V will be equal to 25 plus 6 is 31. 31 plus 7, 38.
38.5.
38.5. Now you have the voltage across this particular current source. So you can calculate power, P equal to V into I, right? So the voltage is in 38.5 and current is 5 ampere. So 5 times power will be equal to 5 into 38.5. Now can anyone say whether this is absorbing power or releasing the delivering the power? So let's first calculate the value, 5 into 38.5. So it is 192.5. So either it is option C or it is option D. So can anyone say whether it is releasing power or absorbing power? That is, it is either delivering or absorbing. Which one is it doing? Just note the positive and negative sign of the voltage and the direction of the current. Anyone would like to say? We have solved similar kind of problem in earlier interaction also, right? Yes, Naveen Raj, you can unmute and speak up. Naveen, if you have a doubt, you can speak up. I see your hand is raised. Okay, anyone wants to comment whether it is absorbing power or delivering power? No? Okay.
हाँ मैम,
Yes.
क्या फिर से
Um, ये
रिपीट?
current source, this current source, is it absorbing power or delivering power? The voltage drop is positive side this side and negative side this side, and current is flowing in this direction, right? So
या
whether this particular source is absorbing the power or delivering the power. Power is V into I. We got it, right? It is 192.5 watts.
absorb ना होगा.
No. See, the basic thing that you have to remember is, if the suppose whatever the arbitrary voltage drop might be, if current is coming out of this positive terminal, if current is coming out of it, it always delivers power. Suppose if the voltage drop would have been like this and the current would have come in, like inside this positive terminal, then it would be absorbing power. Like this is one trick to remember, like whether a particular element, whether it is a voltage source, current source, or like mostly about voltage source and current source, whether it is absorbing and delivering power. See, a resistance will always deliver it will like dissipate the heat, I mean it will dissipate the energy. For this particular like voltage source or current source, always remember, like if current is going inside the positive terminal of the voltage drop, then it is absorbing power. If it is going out, then it is delivering power. Did
Okay,
you
ma'am.
get it?
Yeah.
So the correct option will be option D. In subsequent problems you will come across this again, and I will ask you again. So if you have not understood this, you can like ask. You got this one right, everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, I hope everyone is okay with this particular question. Then we will move to the next question.
Okay, ma'am.
So now another circuit is given, and you have to calculate the value of the dependent current source, that is 10 ix. This particular thing you have to find out. That means you have to find out ix. If you know ix, you can find out what is the value of this dependent current source. Now this ix depends on the current across this particular branch. So we will again use nodal analysis in order to compute it. So let's assume this is V1, this is V2, and this is the third node V3. Okay? Now,
Okay.
yeah. Uh, so again, it is the same thing. Like right now, I'm no longer writing the current equation. Just assume current flowing in a particular direction and start writing the equation. So let's say the current is flowing out of this node for all the three I2, and this particular branch current is given as 10 ix, right? So so it is this will be V1 minus 12 by 4 plus V1 minus V2. So V1 minus V2 by 12, then plus 10 Ix. Ix equal to 0. This will be one of the equation. The second equation will be at this particular node. So again assume currents either going in or coming out like that. So it will be for example, uh, here let us assume current going in this way and then another current going this way. So it is V2 minus of 24 volt, right? So minus 24 by 8 plus so this particular current is going in and these two are coming out. So it will be V2 minus V3, V2 minus V3 by 15, which will be equal to the total current that is coming in. That is V1 minus V2 by 12. So if you simplify this, like, I mean, we'll simplify this later. Then at node 3. At node 3, this particular current is coming in, this particular current is coming in, one ix current is going out through this branch. Let there be another current which is going out. So the node equation at the third node will be um, so v2 minus v3 by 15, uh, and the current that is coming in is 10 ix, and the two current that is going out is ix plus v3 by 10. Now note that this Ix particular branch current will be equal to V3 minus 0 by the branch resistance. So it is V3 by 6. So you see you have three unknowns, V1, V2 and V3. Sorry, you have four unknowns and one is Ix, and you have four independent equations. So now you can solve this equation in order to compute like ix. For ix you have to compute v3. So what you can do is, from the other equations, just substitute like v1 v2 in terms of v3, and then plug it in this particular equation, so that you can compute ix. So one by one you can simplify this. So let's go for I mean, you can do it yourself. It's not much like, it's just like solving the equations, right? Would you like me to try it, or would you like to do it yourself? Anyone wants to say anything? uh, do you want me to solve it, or can you solve it now on your own?
Yes, ma'am, can solve.
You can solve, right?
Yeah.
Okay, just substitute in this case, like, you can substitute ix here in, and it will be in terms of v3. So now, substitute the entire equation v1 in terms of v2 and v3. Then this equation you can solve, like, there is you can again like substitute v2 in terms of v2 and v1, and then put back in this equation. Finally, in the last equation, the entire equation will be in terms of v3. So once you get v3, I'll just see what the answer is, and then I'll, so v3 comes out to be 0.4754. So if you solve this, v3 is 0.4754. Then you can compute ix. Ix is will be equal to 0.4754 by 6, right? So what will be the value of this voltage source? 10 times of this ix. So 4.754 by 6. So 4.754, so it is 0.79. So it falls within the range of this particular option. So option A is the correct one. Everyone understood this one, or do you have any questions? If not, we'll move to the next one. Anyone has anything to say?
No, ma'am.
Okay, then we'll move to the next one. Here, particular circuit is given, and you will have to find the power that is associated across this 2 ampere current source, which means again you have to find the voltage across this particular source. Then you'll be able to comment on the power, right? So let us since you can both use loop currents and analyze it, or you can use kcl, depending on which method you are comfortable with. So for now we'll be just using kcl. This is the two nodes. Let the node voltage be v1 and v2. Now look at this particular node. This particular node is equal to, like, since there is no element connected across this, so these two nodes are same, right? And what is the node voltage across here? Since it is connected to the 12 volt supply, so this is 12 volt. So this again will also be 12 volt, right? So now you apply kcl at node 1. So 2 ampere current is coming in. Let this one be I1, this be I2, and this one be I3. So it will be equal to um, so yeah, 12 minus v1 by 3, and 2 ampere current is coming in, which will be equal to v1. This is the reference, right? So node voltage here will be equal to 0. So V1 by 6 plus V1 minus sorry, I wrote this one also V1. So V2. This will be V1 minus V2 by 4. So you can simplify this and write it in terms of equation V1 and V2. And again then apply KCL at node 2, right? So applying KCL at node 2, it will be, so see, um, this is again like this 8 ohm resistance is again connected across V2 and 12 ohm. So if we assume a current entering I 4, let another current enter I5. So this will be basically uh, 12 minus V2, 12 minus V2 by 8 plus 0 minus V2. So it will be minus V2 by 5. Sorry, it is 6. V2 minus V2 by 6 plus the third branch current is V1 minus V2 by 4. So it is V1 minus V2 by 4. So you have two equations and two unknowns V1 and V2. So you can easily compute this, right? Everyone following up to this much?
Yes, ma'am.
Okay. So I'm not going into the solving this equations, because once you have the equations you can solve it on your own, right? Because we have a restriction of 1 hour time, right? So you can write this in terms of V1, substitute it in this particular equation and find out V1 and V2. So I'll just give the value of V1 and V2 which comes up. So V1 is 10.54. Okay, 54. And V2 will come out to be 7.6364. So once you have V1 and V2, so you basically, if you just solve V1, you will be able to calculate what is asked in the question. So in the to save how to solve these questions in limited amount of time, what you will do is you will substitute V2 in terms of V1. So you will simplify this equation and write it in terms of V1, something by something, whatever it will it be, and then substitute in the second equation so that you can solve V1, because V2 is not necessary in order to calculate the voltage across this particular current source, right? So now I will ask the question again. So you have the node voltage here V1 as 10.5454 volt, and the other side is at 12 volt. So what will be the voltage across this particular current source? So what will be this V? What will be the value of V? You have both the node voltages, right? It is the voltage drop across this, like what will be the voltage across this current source? Anyone would like to say? Let me see. Okay. You can either unmute and speak up or write it in the chat box. Come on, quickly. You have both the the voltage in this particular node and this particular node. So it is just the difference, right? Are you guys sleeping or are you following? Huh?
Following.
Okay. So you get it, right? V will be equal to 10.5454 minus 12, right? Minus 1 point. It is 6454. Everyone okay with this one? So voltage is negative. That is minus 1 point 4 something, right? That means the actual voltage is this way, right? So now we have a current source that is delivering current in this direction, and the voltage across it is in this way. It is 1.4546. So since the current, it will be like the power will be 2 into 1.4546, right? So it was
2.9092.
2.90. Okay, 2.90, whatever. So it is either option A or option B. Now tell me, like, we have solved a similar problem in the previous like we have solved a previously one of like similar kind of question, right? So now you have a voltage source, the current is in sorry, you have a current source, current is in this direction, the voltage is across it is in this way. So whether it is absorbing or delivering power. You'll have to answer this one. You have done it before. Let's see if anyone is.
Absorbing.
Yes. So, as two of you have said, reason, it is entering this positive side, right? So, it is absorbing power. The option is option B. Everyone okay with it? If yes,
Yes, ma'am. Okay.
then we'll move to the next problem. Uh, okay. The next problem, you are given a circuit. Where did it go? Yeah. You're given a circuit and you have to find this VL, that is the voltage across this 6 ohm resistance. So again we will be applying KCL. Let this be V1, this be V2, this be V3. I will write off the equations. Solving you can do it later on. So 12 ampere current is going in, and let us assume like current I1, I2, I3 is going out in the three branches. So it will be, if you apply KCL at node 1, it will be 12 equal to again V1 minus 0 by 4 plus so here what happens is, like, since there is no resistance connected across it, let us assume current. Okay, anyone is coming in, I think. So there is no point coming in at the last 10 minutes, right? You should join early. Okay. um let us just assume like I current is flowing through this particular branch. Okay, so it will be, it is going out, so it is I, and v1 minus v2 by 12. So v1 minus v2 by 12, this satisfies the node KCL at node 1. Then at node 2 it is, so current is going in this way, 18 ampere current is coming out. Let us assume there is another current going in this direction, right? So it will be v1 minus v2 by 12, which will be equal to 18 plus v2 minus v3 by 15. Okay, so um, you can simplify this equation, write it in terms of v1, v2, v3, and the third equation will be at node 3. Here again this I current is coming in, I3 current is coming in, 24 ampere current is coming in, and let us assume one current that is going out. So it is v2 minus v3 by 15, v2 minus v3 by 15. Then it is this current is coming in, then I current is coming in, so let this be I, and it will be equal to v3 by 6. Also 24 current is coming in, so 24 will be on this side. This will be the third equation, right? So just write, take this in this term. So it is V3 by 6 plus V2 minus V3 by 15 minus I equal to 24. This is one equation. Now again, this the second equation is V1 by 4 plus V1 minus V2 by 12 plus I is equal to 12. So this is the first equation, and this one will be V1 minus V2 by 12 plus, I'll just take it this side, so it will be V3 minus V2 by 15 equal to 18. Now if you just add 1 and this equation 2, you can get rid of this I, right? So it will be now two things you can you can so basically now you have three equations, but there are four unknowns: v1, v2, v3 and I. So how will you get the fourth equation? Now you see this 36-volt battery is connected across v1 and v3, right? So basically v1 minus 36 will be equal to v3. So you have the third equation, v1 equal to 36 plus v3. So sorry, this is the third equation and this is the fourth equation. So now you have four unknowns and four equations. So you can solve for v1, v2, v3 and I. Everyone okay with this one?
Yes, ma'am.
Okay. So once you solve all this, I will just write what comes out v1 and v2 and v3. So let me just grab my, yeah. So V1 comes out to be 57.6 volt, V2 comes out to be minus 78.4 and V3 as 21.6. Now the question is, what is the load voltage VL? Now VL will be, so VL is this way, right? V will, and the V3 voltage, the node voltage is in this way. So V3 will be equal to minus VL. So since V3 you know, it will be the negative of VL. So the correct option will be option B, right? Minus 21.6. Okay with this?
Okay, ma'am.
The second question will be a continuation of this particular question. It is the same circuit. Now in this case what you were asked is the power associated with this particular voltage source and the power voltage across this particular current source. So what will be the power associated with the current source? So you have calculated V2, right? So the power of the 18 ampere current source will be V2 times the current 18. So V2 you have 78.4 into 18, right? So
Yes, yes, ma'am.
now can you comment, forget the value, whether it will be absorbing or delivering power. Can you comment on that?
Okay.
So there is, I'll draw it here. Current is flowing across this direction.
Ma'am, absorbing.
Minus. Yeah, could you repeat? If somebody answered.
Absorbing.
Yeah. So yeah, right. So the so the thing is, just think about it once. You see, this V2 is minus 78.4, right? Which means the voltage drop is actually like this. This has a negative sign, right? So the since the V2 is like this, so the actual voltage that is across this particular current source in this way. Here what is happening, current is coming out of the positive terminal. Are you able to follow it? If not, I'll explain again. See, uh, where did my pen go? Yeah. So, yeah, this is V2, and V2 is given as minus 78 point, 78.4. Okay. So basically, if this is V2, that means the node voltage is this way, right? V2, this is V2. But this is a negative value, so the actual voltage drop that is happening across this particular current source will be minus this side plus this side, 78.4. So current is coming out of the positive terminal of the battery, so it is not actually absorbing power, it is delivering power. Did you get it? Did you get what
Yes.
I'm trying to say?
Yes, ma'am.
Okay, I hope everyone has got it. Now you can compute I, and once you compute I, what does the value of I'll just write down what the value of current I is. Just hold on. um, I comes out to be 13.73. So I is equal to 13.73. So it is flowing, and just let me see whether um, so the power. Okay, so when you compute all this, the current direction is actually in this direction, and it comes out to be 13 point something. So 13.733 kind of. So this particular voltage source, is it absorbing or delivering the power?
Delivery.
Yes, because current is coming out of the positive terminal, so it is delivering power. So the correct option will be option C. If you just compute it, power delivered by the current source will be 18 into 78.4. The power delivered by the voltage source will be equal to 36 into 13.76 something. So the correct option will be option C. Did everyone get it?
Yes, ma'am.
Okay. If anyone has any questions regarding this lecture or whatever sir taught, you can ask now. Otherwise, I hope you have understood everything, and we'll call it a day.
Ma'am, question nine.
Sorry,
Question nine.
can you speak a bit louder? You're not audible. Any doubts, anything regarding any of the problems that has been discussed in this interaction session or previous interaction session? Yeah.
Four.
Huh?
Ma'am, please show last slide.
The last slide? Okay. This one?
Yeah, yeah. Thank you.
Okay. So I did not go into solving the equations because it is going to take more than like a lot of time. You can solve it on your own. If you have any doubts, you can mail me. Okay, then thank you all for attending. We'll meet in the next interaction session.